Hello and welcome to another video. I found this question online and I thought I'd go through the solution. So we have a circle. It has inside the circle a cyclic quadrilateral which is broken up into a couple of triangles. So it wants you to show that the side PT is equal to 2r, which is the radius, length, times cos theta times sine phi, that symbol there. Now if you're in Queensland, this type of question is in Unit 1 in Specialist Maths. So you can't use trig identities. It purely wants you just to use circle proofs and geometry proofs. So what do we know about cos and sine when it comes to circle and geometry? Cos and sine we know is part of SOHCAHTOA trig relationships. So we know that cos theta equals the adjacent side over the hypotenuse side, and sine phi equals the opposite over the hypotenuse. Use sine and cos, we need to find right angled triangles. So we know, looking at this, PT is part of a right angled triangle. So the triangle PST. And we know on a line the angles add up to 180. So if you look at this line, this means that angle STP equals 90 degrees. Now, the other right angle triangle that we need to consider is we have to make it ourselves. So we can see here it has 2r. So this is another hint. And this is probably the part that you wouldn't realize without some sort of assistance or unless you're very cluey. 2r is the diameter. You can guess that. But what right angled triangle does the diameter form? Okay, so it forms this right angled triangle. We know that because we know that PRQ equals 90 degrees because of this rule. So a triangle that forms with the hypotenuse or alongside through the center, that's a diameter. The opposite angle is a right angle. Doesn't really help us because it doesn't have theta in it, it doesn't have phi in it. We want something that has theta and phi into it. So this is the tricky bit. Drawing a line from S to Q, we have a right angle triangle here. I want a right angle in terms of phi. So if you look at this here, I call this a butterfly. We may have heard of the butterfly rule. So these two angles are equal. So this angle in here is phi. So now I have a right angle that goes through the diameter 2r and has phi in it. I have a right angle that has theta in it, and it also has PT in it. So if you look at these two triangles, so So cos theta equals the adjacent PT over PS. Again, PS, so the opposite, sine phi equals the opposite, PS over 2R, or PQ. So now we have two relationships that are very important. And this is the final bit. So you want to find it in terms of PT. So we've got, if we multiply these two together, cos theta times sine phi, we've got, substituting in what we just found, PT over PS times PS over 2R. The PS's cancel out, and if you bring the 2R over to the other side, we've got that original equation statement that we were trying to find. So if we call this equation 1, equation 2, equation 1 times equation 2, we get this QED.